Now, in this tutorial, I'm going to talk about adding the results of our box plots into the discussion section of your report. And I thought it would be instructive to show this in both Microsoft Word and Google Docs, because the way that Microsoft Excel and Google Sheets creates box plots are completely different. So what you're looking at here is Microsoft Word, and these two box plots of the speed and the height random variables, this is what they look like. Microsoft Excel identifies outliers. It removes the outliers and creates a box plot with those outliers removed. And so you can see in both the speed random variable and the height random variable, these outliers were identified and removed, and then the box plot was created. And so that creates a very different shape of the box plots of both random variables, which contrasts with that done in Google Sheets. And so this is the same report done in Google Docs, but these two box plot charts were made in Google Sheets. And you can see Google Sheets does not identify outliers. It draws box plots much differently. It does not put a median, and it does not put the mean with like an X. It also doesn't, put these bars out here at the whiskers of the box plots. So how I'm going to talk about these box plots are going to be different than how I talk about these box plots. So let's first, let me show you kind of what I chose to talk about with these box plots here. So what we're looking at are the two box plots and the results. And so I'm going to scroll down to the discussion section. And this is where I talked about measures of center, distribution shape. And now here's the box plot subsection of the discussion section. And so because there was a significant amount of scrolling down, I decided to go ahead and copy the box plot from the results section and put it here, because I'm going to be referencing it as I talk about it. So here I said, figure H and figure I are box plots of the speed and height random variables. So here I've got figure H, which is the speed random variable. These box plots were created with Microsoft Excel. Microsoft Excel automatically identifies outliers, and I put in parentheses solid dots, and removes them from the creation of a box plot. Microsoft Excel also permits the addition of the mean, which is an X point, which you can see right here. In both figure H, repeated below, and figure I, removal of outliers created box plots where the middle 50% is situated evenly between both whiskers. So here's figure H with the outliers removed, and it created a box plot where this middle 50%, this middle rectangle, is situated between both the maximum and the minimum value whiskers. Additionally, the mean, which is this X point, and the median, which is this middle horizontal line, are approximately equal. Both properties indicate that both the speed and the height random variables are symmetrically distributed without outliers. So, what I'm doing is I'm discussing and I'm describing this figure a little bit more. I'm kind of saying this is what Microsoft Excel does. This is what the result is. And because this middle 50% is actually about equidistant to each whisker, and the median and the mean are approximately equal, that means the distribution of the data is symmetrical with the outliers removed. Okay, and so really that's all that I can say about these box plots. This will come and factor in later with scatter plots. but this is it for now. So this is how I described these two box plots in the discussion, but that's much different than the way that I explained it in the Google Docs version, where the box plots look much different. So here we're looking at the results. Let me go down to the discussion. And here's my discussion for the box plots. Now, in this case, it was a little more necessary to actually maybe show the height histogram with the height box plot and the speed histogram with the speed box plot, because I'm going to be comparing these two. So figure N and figure M are box plots of the height and speed random variables, respectively. So here's figure N and here's figure M. These box plots were created with Google Sheets. Google Sheets does not plot the mean nor the median or draw the whiskers in box plots. So there's no median, there's no mean, and there's no whiskers here in the box plots. Google Sheets also does not identify outliers and remove them. Okay, does not indicate outliers and remove them. As a result, the histograms and the box plots of height and speed can be compared. So because no outliers are removed and no outliers are removed from the histogram, these two can be compared. In figure N and figure M, the middle 50% is shifted closer to the minimum whisker. So here in figure N and in figure M, the middle 50% is shifted closer to the minimum than the maximum. So here, this middle 50% is shifted closer to the minimum than it is to the maximum. Hence, both box plots of height and speed indicate both values are right skewed. So because this middle 50% is closer to the minimum, this is indicating a right skewed distribution. And because this middle 50% is closer to the minimum, this is also indicating a right skewed distribution. Okay, then I said the right skewed nature of the speed box plot contrasts with the agreement between the histogram and the descriptive statistics. So what I noticed here is it looks like this is right skewed because this middle 50% is closer to the minimum. But when we look at the histogram and the descriptive statistics of that same random variable, of the speed random variable, all right, you can see that the histogram appears to be right skewed because a bulk of the data is here on the left, and you've got maybe a few values to the right, but you've only got one or two frequencies out here. You just have a few data points, a few datums that are out towards this maximum value. So the box plot makes you kind of believe that there's a lot of datums out here in the higher values. But when you look at the histogram, you don't really see that. And the other thing that you see with the descriptive statistics is because these descriptive statistics are almost equal, that's indicating that this distribution is symmetrical and not right skewed. So the story that the histogram and the descriptive statistics are telling are a little bit different than what the box plot is saying. So that's what I want to describe here. So the right skewed nature of the speed box plot contrasts with the agreement between the histogram and the descriptive statistics. Box plots draw a line to maximum values, but they do not indicate the frequency of the values close to the maximum. So box plots draw a line to the maximum, but they don't tell you really how many data points there are up here. So they do not indicate the frequency of values close to the maximum, an aspect that histograms and descriptive statistics do very well. Therefore, the speed random variable is best represented by the histogram and the descriptive statistics. So what I'm saying here is that even though this is a box plot, of this random variable. It doesn't really indicate very well what the true nature of the data is in the random variable. The shape of the random variable is best described by the histogram and these descriptive statistics. So you've got kind of two methods of analysis agreeing with each other, and you've got one that's disagreeing. So you want to really kind of use the methods of analysis that are agreeing with each other. And we've got good arguments to say why that is. Over here, the reason why I didn't talk about these two is they're pretty much in agreement. So the middle 50% is closer to the minimum, which means that this is right skewed. And here we have a histogram, which does have some values, more values here in this upper higher range closer to the maximum. And our descriptive statistics, the mode, the median, and the mean are not equal to each other. The median is greater than the mode, and the mean is greater than the median. So the mean and the median are getting pulled towards these maximum values, which is indicating that this is right skewed, which is the same story that the box plot is telling. So all three of these appear to be in agreement, but there is some disagreement between the histogram and the descriptive statistics for the speed variable versus that of the box plot of the speed variable. So two greatly different interpretations of the box plots with, the histograms and the descriptive statistics, just because I plotted the same data in Google Sheets versus Microsoft Excel. So I wanted to give you examples of both so that you can learn something and maybe find a closer parallel to the results that you're getting, and to give you some help as to how to write about it.